Hello everyone. It's nice to see everybody on this webinar. So I propose to wait maybe 30 seconds until everybody connects. Okay, so welcome everyone on this Webswing's webinar. We are going to talk about the Webswing 23.2 major release, this is a version that was released now in October. We are very excited to present you all the news coming with this version. And it's mainly about the release and the new components and the migrations features. I want to thank Branislav and Viktor, who were mainly preparing this presentation. So, I can also move the slides. So let's move to the other slide. Okay, so mainly to Viktor, who is the CEO and the founder of Webswing. He's doing Webswing since 2012. And Branislav, who was the key architect of all these new features in the version 23.2. So these two gentlemen are going to present you the features. Myself is Igor. Probably some of you already know me from the business part of Webswing, not from the technical or technological part of the Webswing. So we are looking forward to present you what we prepared. What is it going to be about? Webswing 23.2 release and new components migration feature. So new features in 23.2 Webswing version, the component migration, what was our motivation, how it works, the demo, and on the end, your questions and answers. Please, there are polls, so you please answer these two little questions to us. That will be very helpful to us. And also, please feel free to ask any question during the presentation. Some questions we will directly answer in the tool. Some of them will be discussed live. Let's see. So thank you everyone again, and I hand over the word to Viktor.
Hi everyone, and thank you for joining our first webinar. Hopefully first of many. Also special greetings to all the familiar names I see in the audience. Yeah, I'm happy to show you today what is new in our long-awaited new LTS release of 23.2. Maybe first, let me give you a brief introduction to some, let's say, appetizer features that we included in this release, and then we will get to the main course, which is, of course, our new migration approach. Right, so let's start with the anticipated Jakarta EE support. I'm happy to say that we not only added the support for Jakarta, but we managed to keep the builds backwards compatible with the Javax EE. So you can now deploy the same Webswing WAR file to Tomcat 9 or Tomcat 10. It should work. It should work fine. Maybe one aspect that's worth mentioning is that we still consider this a breaking change because unfortunately we had to change the security API, so it will affect existing custom security modules if you happen to have one. But in these cases, you just recompile them with the newest security API dependency, and the only difference should be the package names. So the only change you need to do is update the imports there. Okay, the next, then we have the configurable file viewers. If you happen to be using the AWT desktop class to trigger file downloads in your application. Now you can configure what URLs should be used if you call open, edit, or the print methods for a selected file type. So, for example, if your application generates a CSV report, until now you could only download the CSV report because all three methods were essentially doing the same. But now you can, for example, define that for the open function, you want to open the CSV report in a web viewer. Or you can simply decide to use a browser's built-in viewers for file types like images, HTML files, or PDF files. What I'm most excited about, that in near future, we will add support for URI schemes as well, so that you will be able to open directly the CSV file in Excel, for example. I think this is quite a simple feature that can be quite powerful, which I don't understand why we didn't add this feature before. Yeah, finally we have it. Okay, let's continue with the next one. Next are the new ways of handling user inactivity. This is essentially an improvement of our current user inactivity monitoring, where the only option was to shut down the session if the user was inactive for some defined time. But now you can also choose to disconnect the user or choose to log the user session. And when you log the user session, the session will remain active and connected, but the user will be forced to relog in to continue using the application. Okay, next, the drop-in deployments. This lets you create a self-contained application package that you can just upload to the Webswing server and reference it from the main Webswing config. You can, for example, build your application that will generate this drop-in package that you can just directly upload to the Webswing server as a new version of your application, for example. All right. Then we have the new input mode that lets you mark Swing input fields to open a specific type of keyboard, like for example, numerical, or for URL entry, or for email entry. This is, of course, only for touch mode, or touch-based keyboards. And this functionality was actually completely missing from Swing, so we added it as an extension to Webswing. And the last one from our selected set of features is the Webswing PDF printer that now supports embedding of fonts. That means it will now generate much smaller PDF sizes. If you're generating PDF files that are large that have many pages, it will generate smaller PDF files that will look exactly the same as you would expect from the application. And you will have a text selectable in the resulting PDF. And now, as I promised, the main course of today, which is our new migration, component migration. So, as you may already know, prior to this version, we already had a way to combine Web UI and Swing UI, and this way does provide a great base for extending your Swing application with web functionality, or even integrating the Swing UI to your new web new web-based applications. And we still consider this feature foundational, and it will work as before, as many of you are already using it and rely on it. However, what we see as a downside of this existing functionality is that it is kind of invasive to your Swing application. So that changes needs to be done to your component structure, to your business logic, in order to include the HTML panels, and then displaying of the actual web part is very loosely coupled to the Java code, where you have the HTML panel, which then requires a lot of manual work to synchronize the two sides. And this, in result, makes the development quite difficult. And this is why we decided to add a new declarative way of migrating, where you do not need to make breaking changes to your application. So we wanted to make the migration code, let's say, additive. And by additive, I mean that the migration will not affect the application, not affect how the application behaves when it's running in native Swing. But as soon as you start it inside Webswing, while the migration is enabled, it will render as a web-based application. If I should summarize this feature in one sentence, it would be something like you extract the state from a Swing component and show this state in a web component. But of course, it's not this easy. To achieve this, we need essentially two things. First, we define what state we need to render, or what state we need to render a component, and then how to extract this state. And the second thing we need is we need to be able to handle events from this web component and translate them to the underlying Swing events that will be based on the component that the web component is associated with. Of course, there are a lot of other technicalities that need to happen in the background, but please just let Webswing take care of those. With this new way, we can effectively create a web-native look and feel, where components are rendered as web components, and of course you can apply this also to custom components. And also, if you have any components that are not marked for migration, these will still display as canvas, as rendered by the Swing framework in the background. In the current state, we consider this new feature as a foundation for new functionality that we will add later. And this is also why we mark this feature as beta for the time being. And we still reserve the right to do some minor changes to the API because of these new features that we are planning in the future. As soon as we mark this, as soon as we remove the beta, that's the time when we will freeze the APIs, and then from that point on, they will be stable. Anyway, the feature is now available, so feel free to experiment with it, and we will appreciate any feedback. And now Branislav will show you how this works in real life.
Yes, thank you, Victor. Okay, hi everybody. Let me tell you something about how the component migration works behind the scenes first, and then I will show you the demo. So If you are familiar with Swing, you know that every component extends a J component, and this J component has a property called UI. This is basically an implementation of how the component should look like. So when the toolkit wants to render or paint the component, it calls the paint component method of the J component, which then delegates the painting process to the UI class. So with Webswing migration, what we can do is we can replace this UI class with our UI class or whatever implementation you give it. And you can do this similar to how look and feel does it, because when you change the look and feel, what it does, it actually changes the UI class. So it's like a plug and play mode. So in our implementation of the UI class, we can control the rendering process of the component. And in this process, we extract the state. The state can be anything that basically you need for the rendering of the component on the front end. So it may be a text of the component, it may be the disabled state or whatever. And then in our rendering cycle, we take this extracted state and we send it to the browser. And in the browser, we can then render a web component. So this is basically classic HTML component, which is custom made. Okay, so enough with this boring stuff. I will share my screen and show you the demo. Okay. Okay, so this is a simple application in Swing. We have some button components, we have some labels, we have some inputs here. So nothing is migrated yet. So this is all painted on a canvas, just like we are used to. So now let's try to migrate something. So we have this new migration, Webswing migration API. And let's say we want to migrate all the buttons. So if we uncomment the single line, what we tell Webswing is that every J component that has registered this button UI class, we want to change it to this our implementation, WS button UI. Okay, let's save it and let's see what happens. Okay, so now let's see the buttons. You can see that these buttons are not painted on a canvas, but these are Webswing button. And inside they have shadow root with this button element. So this is great because now all the buttons here are HTML buttons and all the other stuff is just plain canvas like before. So what we can do here is we can take this button and you can just quickly change its CSS, like font weight bold. We can add its border. We can make it, color red. Maybe make it round. So this way you can really quickly change the visual aspect of your previously J components, now web components. Okay, so this is nice, but what if we want to just change some of the buttons, not all of the buttons at once? So maybe we have some kind of buttons that need to have some different class or whatever. So what we can do is we can apply this migration filter in Webswing API, and here we say that in this should migrate method, if we get the button UI class, we want to only migrate buttons which have this migrated button class. So if we do this, Now we have only these 3 buttons migrated. So we have filtered out, and we can filter out on anything. We don't have to use the class. We can filter out on some property of the button or whatever you need. And these buttons, as you see, they still work if you click on them. So these labels still change when you click on it. So, okay, next thing I want to show you are input fields. So now we have 2 input fields, both are painted on canvas. So if I type something inside, it changes the label at the top. Let's try to migrate it. So I will again migrate the text field UI, and we have also applied the migration filter. So I will migrate only a single text field from the view. Okay, so it looks really the same, but if you take a closer look, this is a Webswing text field, and inside the shadow root, here's a HTML input, and this other one is still canvas. So let's see what's the benefit of this. You see that it still works the same, it looks the same, but what if you have a really bad network connection? Some of our customers have really bad network conditions. Let's say we have bad latency and also bad speed. So when we type into Swing input, what happens is I type, but I have to wait until the text goes to the Webswing, and then it renders into the input, and the input is rendered into the canvas. So there is a huge lag, and this is how it looks like if I'm holding backspace. So it's really slow. So the benefit of this migrated input is that I can type, I can see what I type right away. I don't care about the lag. I can naturally type in, and I don't care that there is a lag because it will just show later. But at least I can naturally type. So this is a benefit that migrated input can give you. You don't have to migrate your whole application, but maybe if you have a slow network, you can use this. Okay, so let me disable the throttling. Okay, next thing I will show you is a complex form. So a lot of our customers have forms of some kind. Every application has some kind of form. So this is again some form. We see the feedback on the bottom. Now both of the forms are canvas, so there's nothing migrated. But we could migrate this component by component. So we could migrate the text field, we could migrate the combo box, then radio button, checkbox, and button. But what if you want to migrate the whole component as a single unit? So we want to change the whole component, the whole form, not just a component by component. So we also can do this. I will show you how. So here I have a personal form, which is basically JPanel. It has all the controls inside. And what I changed here is this UI class ID. So I override this from JComponent, and I give it our custom component UI class. So it won't be a panel UI. This one will have this WS personal form UI. So we also have to implement this. Since it's a JPanel, I will use basic panel UI to extend from, and I also need to implement our API class WebUI. So in this WebUI class, there are 2 methods to override. First is extract state. So here I say that I want to use a WS personal form as a web component file, and then I provide some properties. That could be anything. So it's a string map. So I will just put all the stuff I need from the form, from the controls. And also I need to take the value spec from the web form and set it to the Swing form, to the Swing controls. So here I'm handling a web event. This is a custom event I sent from the web component. And here I'm just setting back the values. And the most important part is probably this paint. We override this paint method, which we tell Webswing that with this paint web, this is a default method of WebUI, that we want to paint a web component. So if we are successful to paint the web component, we just that's all we want. If we're not, we want to paint with the extended UI. So let's see how this looks. Of course, we need to enable the migration. So here we tell that this UI class will be migrated to this UI class. And what is also important in this migration filter, we need to mark this UI class to be migrated fully, which basically means that all the components inside this personal form will not be resolved. So they will not be even painted or migrated or anything. So this means that this is a single unit. Okay, so let's see what it does. Okay, so here we have a nice web form. We also saw that in the presentation. So now you can see we have AWS personal form. We have some custom CSS attached to it. We have controls inside. And what's great about this, we also have this like feedback. Naturally, everything works. What is great about this is that we don't have to have the same order of the components. We don't have to have the same layout. We don't even have to have the same components. So I can like remove this input and don't even have to care about it. Or we can add some more inputs to this, some more controls or whatever. So this is how you can migrate, like not just like form. You can migrate like a whole dialog or whole view to a single web component that just renders the view. Okay. The third example is a chart. A lot of customers have charts. They use a lot of resources, of course, on the server side. If they are like 3D like this one, this is an awesome charts from JFree. And most of the chart components are like from third party, so we don't even know how to migrate it because you don't want to touch it. You don't know how it's rendering. So I will show you what we can do about this. So here I have a pie chart panel. This is basically a JPanel that has inside this chart 3D panel. This chart 3D panel is a org JFree chart 3D. So this is the third party component. What we can do is we can implement again the WebUI interface where we say the state of this web component, the name of the web component is AWS chart, and we send the data as a property. So the data is the same data that you see in the chart. So this is the chart data. The next important thing to do is register this component. So we tell Webswing API that this chart panel will be rendered with this as this web component. So you can see I have a toggle button there. So you can also unregister it in runtime. So this is not like a static thing. And the last thing you need to do, this is the original code. So you have something like this. So what we can do is we can do an anonymous class and we can override paint component method. And in this paint component method, we again, as you saw in the personal form UI, we can ask to paint as a web component. And if it's successful, then we will just end here and we will not paint the chart. So if you would call this, we will again paint the chart. So we don't want to paint the chart on the backend. So we want to save the resources. So what we want to do is to make this web component to paint the component. We are using some JavaScript library to do that. So here we don't need to actually do anything else. We don't need to migrate here something, because all we need to do is here in this class. So it's like self-contained. Okay, so let's see how it looks like when it's migrated. Nice. So here we have, you see that this is some kind of SVG rendered. So it's nice, interactive. And it's really only about the paint component methods. So this is how you can easily migrate also like a third party components that you don't know how you would do that. Okay, so if you still have time, I will show you the last demo I have prepared. Here we have, it's similar to the chart. It's a custom painted component, but this time this is a plain J component component. This is some rendering of an image and text. We have some speed control here. We can start and stop it. So let me show you how we can migrate this. So this is basically a J component. We don't have any UI class here. We can migrate through a UI class, but we have a paint component, which basically this is where all the rendering happens. So we can do the same as in the chart, but we can directly implement the interface here. We have extract state, we have the web component name, we add the running property, we also register it, we have toggle button. So, and again, as with the chart, we have this paint web method, which if successful, we don't want to paint the original thing. So let me show you how this looks like when it's migrated. Right, so now we have migrated this to an image inside the div, and we can apply some CSS to make it rotate, to make some animation, right? So, but the speed control doesn't work now. So I made this on purpose so I can show you how quickly you can migrate something like this. How can you make work this slider? So let me show you what needs to be done. So here we have a field called speed, and what we need to do here is only add it as a property. So I will edit here speed. Okay, and now I will show you the web component. So here we have the web component. It extends the basic HTML element. It has one property, internal. We will add another. So we will store the speed here. And what we need to do, we need to add a getter and a setter for the property. So we want to get speed. We will return this underscore speed and a setter. And this is this equals no or parse int. Okay, and we also need to call render so that this component re-renders. In this render function, we have like this very simple. We will just adjust the animation speed. So let's say style, animation, duration equals 100. This speed plus seconds if we have speed. Okay, let's see if we've done it right. Refresh. Okay. Oh, nice. So now it works. So you can make it really fast or really slow. So this is how quickly you can just add some property to web component. It's really easy, I think. Okay, so much for the demo. My word to Victor again.
Thank you, Branislav. Thanks for the demo. Hope you guys enjoyed it. Okay, how do we get back to here? Right. So before we jump to your questions, let me just quickly tell you what other functionality that we are working on that is built on top of this new migration capability. Our primary focus at the moment will be to add a way to control the layout of the components from web, as currently the component layout is still controlled from the Swing framework. So that's one thing that we are working on. Next thing is we are planning to create a base implementation for the web native look and feel that you can then extend and add the necessary functionality that you need. Another thing that we want to leverage is the fact that with this feature, we can now tell when each component is being rendered, and that essentially gives us the ability to add additional component level caching to direct draw, which I think could dramatically increase the rendering performance and improve testability and accessibility will be kind of a direct benefit of having the application render in what's a web element structure in regular DOM. Yeah, that's all from this. Thank you for your attention, and I think it's time for your questions. Okay, so let's see. I already answered some of the questions in the application while Branislav was talking, and there are still some unanswered, so we can go through those live. So here, which types of Swing components are supported, e.g. JText field, and which subset of features? In particular, how about JTable and the cell editors? Branislav, do you want to answer this?
Yeah, well, basically, as you saw, like any component, you could migrate any J component. Everything that extends J component can be migrated. What subset of features depends basically on you. You can control what you need to have in the web component. We will try to give some reasonable default for every component, but there may be some. We cannot migrate everything from the component because many users use different stuff from the components. So there's a wide variety of properties and stuff. And it's not always easy to automatically implement them in a web environment. And JTable and cell editor that gave us a little headache last couple of weeks. The cell editors are special because they are not really attached to the component tree, but they are like components used only for painting. So it's a bit of problem, but I think we have resolved it. And JTable, I think we should migrate it as a like more complex web component, not just like parts of it, but like make it a more complex, because it's really a very complex component. So we didn't have time yet to do this kind of migration, but we will try to make all of the basic J components in the 24.1.
Or hopefully sooner.
Maybe.
Okay, let's get to the next question. Could you elaborate on what additional features you have in mind for the component migration in the near future? I think we have answered it on the last slide. Yeah, it's mainly the layouting. The second thing is the base for the web native look and feel. And third one is the second level cache for directory, which should improve rendering of everyone, not only for those who do the migration. I hope this answers your question. Let's get to the next one. Can I add my own web component mappings? Can I customize existing mappings that were created by you? Yes. Branislav, do you want to expand on that answer?
Yes, I think you should add your own web component mappings because it's your application, so you should be responsible for what you want the web component to look like. I mean, we can give you some kind of like default, but it's like even when you get the default swing look, like it's not pretty. So you want to like make it better, of course, always, and make it your own way. So yes, you should be doing that, and we want you to do that. And
yeah.
yes, you can also customize the existing mappings. You just take the file and you can copy it or extend it or whatever.
Yeah, so that this you can do already at current state. What we're planning to add is the base for the web look and feel that you can then take and extend it and add your function, add your look, add your CSS and so on, and extend it for your needs. But essentially, you can create these web components and create the mappings yourself at the moment. That's how the demo that Branislav showed is working at the moment as well. Okay. Another question, will the test tool work with the hybrid application migrated or not migrated? Yes, we will update the test tool, but of course our test tool is, let's say, for basic testing. QFS tool is already capable of doing this. But yeah, we plan to update our test tools so that it works with these migrated components as well. Okay, let's get to the next question. Do the components respect clipping due to layout, scroll panes, and or cell editor bounds?
Yes, they should, because what you don't have to send in the extract state is the position and the size, because we do that internally. So every time you have a migrated component, it gets the same bounds of the J component with respect to viewport. So yeah, the clipping should work fine, but you have to realize that it's clipped in a Swing environment and not in the web environment. So you might not be able to clip the web content, if you understand. So it's not perfect, but it should be where it is, where it belongs.
Also, this is part of the next steps, as I mentioned in the last slide, where we want to improve the the possibility to lay out the components from the website. You can, to a certain extent, do this already, but not in a case where you are combining layers of component, where you have a parent layer, which is a migrated web component. Then inside that migrated web component, you have a non-migrated web component, which then contains another migrated web component. But from the outside, if you have only the outer layers, can control the layout of the inner layers, but not if you have a embedded layering of different types. But hopefully we'll resolve this in next versions, next releases. Okay, let's get to the next one. How do components canvas deal with multiple overlapping components, e.g. dialogues or models? Do these need to be all web components if they're not the bottom layer?
No, it's as you would expect. So you can have like Victor said, a migrated panel, inside is non-migrated panel, and inside is migrated panel, and you can combine it in any layer, in any depth you want. So this is not something, not a restriction. This can be combined freely.
Yeah, so as soon as Webswing detects that there is a migrated component, it will render all its siblings as canvases. It will create canvas for all the siblings of that migrated component if those siblings are not migrated, and therefore you can combine, mix and match migrated and non-migrated. So you can migrate containers as well, which will contain then non-migrated components, which will be then rendered as a canvas. Okay, I hope that answers your question. Next one. I assume the end goal of migration is to be able to set overall look and feel once, and all components will become web components. All clipboard features in web page, things like selecting some text, right-clicking, and having a normal pop-up for things like search for selected text and so on. Branislav?
Yes, you as Victor said in the presentation, we want to create some kind of web look and feel. So you could like migrate all the components at once, but it depends on your application if it's appropriate in your application or not. Of course, there will be maybe some issues with some things, but yes, and regarding the features, selecting text right click is the same as if you have normal web elements. So if you can select the web element, you can select the text and you can copy it. And if you're asking if you can then paste it into Webswing, I think yes, that should work out of the box. And any other events you want to create or trigger or handle, you can do it in the web component. There's an if you have seen the text field migrated, so we use a custom event when we grab the JavaScript event of input and we send it to Webswing with an interface that is provided in the web component, and then it's handled in the handle web event method. So it's pretty straightforward communication between the web component and the web UI implementation class.
Okay, thank you. Next one. Can we use an is Webswing flag to still run native Swing with WebStart and the new migrated HTML components in web mode. Yes, so that's essentially what we are trying to do. Is with this new migration, you will be able to do the migration in a way that will not interfere with the functionality of your application when it's running in native Swing or in WebStart. But as soon as it is running in Webswing and the migration code is present in your application, then it will automatically render as a web application. That's one of the main intentions of this new migration. Okay. We have a Swing application which uses the MDI pattern realized with internal frames. Does the migration API support internal frame? Branislav, would you like to answer?
What's an MDI pattern?
I don't know.
Okay. Anyway, yes, we support internal frames. I don't know if I have to make any more comments about it. Yes, we do.
Yeah, it should work as any other component.
Actually, what we did is we also, we had the HTML panel before. We also implemented it through this new migration API. So HTML panel is just like any other component you would migrate.
Perfect. Okay, let's get to last 3 questions. Will FX components be supported as well in the migration to web components? Well, hopefully in the future. Yeah, currently the migration only works with Swing components, but I don't see a reason why we shouldn't be able to extend it to JavaFX. But to be honest, we haven't analyzed this option at the moment. Anything you want to add, Branislav?
No.
Okay. Follow up on your previous answer. Is there a performance impact for having multiple or many siblings or nested canvases? Yes and no. It's hard to judge. If there are, it depends on the situation, I would say. The canvases, if there are many small canvases or many siblings that either have or have not migrated, it shouldn't be much different compared to everything migrated. So probably not. It's hard to answer. Branislav, would you like to?
Yeah, we're still in beta, so we didn't really take any measurements on this, any benchmarks. Yeah.
Yeah, well, let's say probably not. Okay. Beyond the current migration means that you're putting in place, do you envision providing Java APIs to get rid of the Swing tree, namely J components, and send only data from the server to render them directly in the web browser by the Webswing middleware? This would be quite complicated because at the moment most of the Swing applications contain a lot of business logic in the components, and essentially with the migration, if the migration is enabled, we're completely skipping the paint method. So the raster, the painting of the components that are marked for migration is not happening in Swing framework. So in that case, these J component classes are essentially just a controller layer for the web components. Right now, I don't see how we could get rid of the Swing component tree and still kind of support easy migration, because that would require a lot of work on the application side. Don't know if I answered the question or not. Branislav, if you want to add anything.
I wasn't actually paying attention, sorry.
Okay, let's get to the next question then.
Yeah.
Oh, there's still three questions. Is it possible to migrate an application that only uses Swing components? No 2D or 3D graphics, for instance, so that it does not have any dependency to Webswing objects or packages? I'm not sure if I understand the question. Oh, if I think about it, yes. You would need to create like a main method wrapper that would contain the migration logic, and then execute the main of the application that you want to migrate. And that way you actually don't need to do any changes to the application itself, but you would only have this main wrapper that would set up the migration mappings. So what component should be migrated, how. And that way it should be possible. And if you have, let's say, if you have custom components that are not part of the base components that are rendered through look and feel, then you can still add UI classes to those components in the application, and then map those in the main wrapper. So yeah, in essence, this should be possible. Okay, let's get to the next question. Can you show how data is dealt with to send back and forth between Java and the JavaScript HTML components, data-bound controls?
I'm not sure what's dealt with, but
I think what I think this is the state that we are sending.
Yeah, so you can send any stay like as a string, but I think we could support binary too. So basically, anything you can just.
So the application, when it's doing the migration, it will create a tree of extracted states. Like we have this extracted state object, which tells the browser which component should render as, what is the web component name for that component, and what are the state parameters as a map. And this after the rendering is finished on the Java side, this is composed to a tree-like structure, and there's of course a mapping, not a mapping, a diffing mechanism where we check what is the current state of the UI, and what is the new state, and we only send the updates, and Webswing will take care of creating and removing those parts of the DOM that are no more relevant, and create parts that are newly added, and so on. This essentially works like a reconciliation process in the React framework, but the state is held on the Java side while rendering is still happening in the browser.
Yeah, and every property you put into extract state is basically a property on the HTML element. So it's an HTML. It's a property of the element. So in JavaScript, if you have the element, you can access the property that you sent in the extract state. And you can do whatever you want with the property inside the HTML component, the web component you implement.
Okay, cool. Let's get back. I think we are on the last question. Could you please elaborate on event handlers on focus on click?
Yeah, as I think you're referring to on focus on click on the J component, not on the web component. So what we did, we want to make the events transparent. So if you click on the canvas and on the place where you clicked is a button, then it just triggers a mouse click on the button, right? So it's natural. So we did the same with the web component. So we propagate the same event, even if you click on the HTML button that is migrated, it will just trigger the same event, and it should basically do the same. It should focus the button, and it should do the action listener on the button, because that's even before, if you clicked on the canvas, it was just the source of the event was the mouse click, and the button itself triggers the focus and the click and the action listener and all the mouse listeners. So this is basically handled transparently. What is not handled transparently is keyboard events, because it's a bit more complex with the text field. So we don't really propagate keyboard events on the web components now, but you can easily handle those keyboard events, input events, as you saw on the text field migrated component.
Okay, perfect. Okay, one more question. We're using a lot of third-party components like JGoodies forms and Jite components. Do you expect problems when migrating these components?
It depends. I don't really know the internals of these third-party libraries, but as you saw with the Orson charts, if you have like access to the component, and you can create an anonymous class, you can override its paint component, but it's a bit of a bigger intrusion into the code, like instead of just like migrating by the class ID. But if the components have like custom UI class IDs, or you can filter in the migration filter based on their class or something like that, then I think you could just intercept these and create an implementation of web component for these.
Okay. Thank you. One more question. What do you see as the main limitations between a complete React rewrite of the UI and migrating within Webswing? What can't we do?
What can't you do with React, or what can't you do with Webswing? I mean, I think with Webswing you have the benefit that you have still the Swing application as a backend, and you don't need to implement another backend.
Yeah. Essentially, with Webswing, you can keep the business logic of the Swing while still having a native web-based UI.
Yeah, as I told in the personal form, you can just take the whole frame, like a panel or a whole view, and you can say that this is my web component where I implement all the logic that it's inside, and you just implement it inside a single web component or multiple complex components, whatever. And this can be like a part of a React page. This can be a React component, and you can put it inside another React page, and you don't have to see the Swing, but it can be on the backend still.
Yeah. So essentially, you can create the web components in React or in other web frameworks.
Yeah.
That have all the nice features where you can develop mappings and reactivity and so on. Okay, cool. I think we have answered all the questions. Hooray.
Thank you, guys. That was fantastic. And thanks, everybody, for the questions. And thank you as well for the fantastic feedback we received from you. Very, very, very much appreciated. Thank you for your time. It was 7 minutes longer as we planned. So there will be a recording. We will be sharing this. And please, if you have any more questions regarding whatever was discussed or whatever about Webswing, please write us at support@Webswing.org, and we will be happy to schedule individual calls with any of you and answer questions more in details. So thank you again. Thank you very much, and have a good day.
Thank you, guys.
Thank you.
Bye.
Bye.